Hello, my friends. My name is Anton Koniluk, and today, together with Jeff Tantsura from Apstra, we will discuss one of, I think, very interesting and still kind of hype topic, because the topic that we will discuss today, you might even not yet probably hear, but definitely don't know what is it about. Hello, Jeff.
Hi there. Thanks for having me.
Yeah. So the topic that we are going to discuss today called, share my screen. It is called an intent-based networking. So, Jeff, when you hear about intent-based networking, what is it? In one sentence.
So, intent-based networking defines outcome of a distributed system. So, you define what you want your network to be. You don't think about, I need to configure VLAN here, EVPN leg there. You define the outcome and let IBM system to take care of instantiation of the state.
Okay, sounds very interesting. And that's exactly the topic why I introduced, why I invited Jeff to talk today. So that's briefly about Jeff. Jeff is currently head of network strategy in the Apstra, the company who's actually dealing with intent-based networking, and the company who's developing the product for that. Jeff is very active in all the kind of networking body, let's say, in Internet Architecture Board, IETF. You could see a very impressive list of RFCs that Jeff has authored or co-authored. And recently he has released a book, Navigating Network Complexity, together with Russ White. Based on the profile that I have looked in the LinkedIn, Jeff has worked almost 25 years in the industry, and that is network profile, so you could follow Jeff on the LinkedIn as well. So when I was discussing initially preparation of the session, so I was asking the same question. So what is IBM about? So how you could describe how this picture is related to IBM?
So IBM is a reasonably large topic, and in order to understand its complexity, we need to take a holistic view on what we are trying to achieve. So if you take a partial view on your network, you get what you see on the picture. It might be wall to one, rope to another, or tree to third person looking. So if you could take a step back and say, look, it's an elephant, and wherever you look, you see different details of an elephant, but as a whole, it's an elephant. IBM takes same principle. We treat a network, a service on top of network as a whole, as desired outcome, as your intent. And then we are going back to model it, to instantiate it, to make sure that your intended state is in sync with your operational state. Actually, other way around, that your operational state is what you want it to be. So the point of this picture, you need to take holistic view of whole network. Just doing one thing is not enough. It's not going to lead to desired outcome, but only to partial outcome.
Okay, so meaning what you're saying that in order to understand IBM, we need to look on the network, and not only on the network, but also on the operational state, comparing to the state as it should be. Is it correct?
Absolutely, yes, it is.
Okay, great. You also said interesting topic. So you said that IBM is a kind of SDN 3.0. What does it mean actually 3.0? Because still people think in SDN, yeah, probably it's kind of magic.
But actually, I don't particularly like the discussion going into SDN. I don't want to compare things and talking about what done right, what done wrong.
Okay. Thank you.
The point being, and there've been a lot of discussion about what IBM is. In my company, Apstra, we really pioneered the concept of IBM, and we've defined a number of levels for IBM. So where we said 4 levels, we mean level 0 is really basic automation. You can go and write number of scripts that configure a VLAN, IP address, SVI, whatever not, right?
Absolutely correct. And I think that this stuff is a lot of companies trying to do, a lot of kind of, optimize the time that they're using for the operational tasks, configuration VLANs, provision of services. And the scripting, I think, is around 20 years, and they already was in. I think they will still be around, but yes.
Absolutely. So there are a number of scripting tools. There's a lot of open source that's doing really good job for day zero operations, for configuration of devices, right?
Yes.
It's a repetitive task. It's easily automatable. However, it doesn't deal with any changes. And your network becomes brown field 5 seconds after it had been green field. So next step, a natural step, would be to converge towards single source of truth, because there are many different sources and someone has to normalize all the data, make sure it's consumable, it's understandable to a system. So when we look at level 1, the number of, I wouldn't even say project that could potentially do this, that try to do this quite complicated task, takes a lot of work and know-how how to do properly. Level 2, and we are talking about steps that build on top of each other. If you didn't do basic automation, single source of truth doesn't really matter. If you don't have single source of truth, there is nothing you can reason about. So level 2 is real-time change validation. What do we mean by that? At any point in time, you should be able to query your system. Is my intended state still as it should be? Are there any changes? And if there are changes, are they meaningful? Okay. So it could be as simple as crossing particular threshold on interface drop. Could be as simple as queue depth occupancy going. Could be as complicated as tell me which customers affected if 3 of 17 links on my fabric go down. So the ability to constantly compare states is fundamental to IBM system. And when done right, could lead to level 3, which is the nirvana of IBM. It's really a self-operating, self-healing network. So when you can understand the changes and could remediate, bringing your system back to the intended state, your network becomes self-operating. We are still far away from this point of view. We as humans don't really trust machines to take decisions on behalf, right? So there's obviously going to be a red button for quite some time saying, this is what you do, this is what you don't do, I trust you so much, right? But in order to get to self-operating network, it's mandatory to meet all the levels. Okay. So if you look at slide, you could see that the number of variables in terms of tooling. So scripting we discussed, there's a lot of scripting tools, Napalm, Ansible, Chef, a lot of stuff around, right? Gives you multi-vendor, if you wish, gives you quite some flexibility in how you do it. However, it's quite limited to what it can deliver. Okay. Going down toward more vendor specific, there are NMS tools. Most of them are very vendor specific and support only vendor who builds them. So if you look at traditional networking vendor, you will see a number of tools, we don't have to name them, that support only hardware made by this particular vendor. And intention of IBM is to be multi-vendor. We abstract differences between the vendors. We abstract the semantics. We consume the intent and instantiate networking, whatever vendor it is.
But it is very interesting topic that you're saying. So we need to have a kind of source of truth. How do you build this source of truth? Because even if you rely, let's say, on the configuration could be faulty, right? So the real state of the network comparing to the physical cabling might be different. How you verify or how you really create this source of truth?
So it's a fundamental departure of how we've treated network for the last 30 years. We always use configuration as source of truth, which is not, it's just not right, because the configuration is really rendering of your intent. And probably for all the vendors I've worked with, Junos was the closest one where the configuration is really rendering of your intent, right? So
okay,
we treat configuration as a result of intent, not the other way around. We don't look at configuration to tell what a system does. We produce the configuration as outcome of composition of intent. So if you look at single source of truth, it's a database, if you wish, that has all the intent modeled and all the additional data and metadata that needed to instantiate networking. So if you say I want a leaf-spine network 4x8, we can model the network. However, you still need to provide IP addresses, ISNs, and all the additional information that needs to be incorporated into data model. So by building such a system that incorporates all of them, you build single source of truth, and we will get to analytical part, but it also needs to be able to take the telemetry and apply it to your networking graph and decide what is the meaning of the changes in your topology, in your load, in any kind of metadata that comes from your network.
That sounds really interesting, because if I understand you correctly, it means that the source of truth, by the end of the day, yes, it is built from the network elements, but then it is rendered to kind of abstraction that your intent is. Is it correct?
No, it's the other way around. It goes north to south.
Okay.
So if you look at how you build, intent comes from the kind of northbound, right? It comes from OSS BSS layer. It comes directly from user. Someone has to express their intent. What single source of truth does, it compiles all the intent in a way it could be used for instantiation of networking southbound. So from workflow perspective, it's really intent consumption, intent composition, and then instantiation of networking that could be done through creating configurational files. It could be done through using something like netcon, gRPC, YANK. It could be done by any way and system understands and could be configured. So we create configurational state. What's important, the way you interact with end system is completely hidden from intent provider. So it's the role of IBM system to take high-level intent and instantiate low-level networking.
Okay, that's now it is more clear for me. Thank you for that. So that's exactly the point. That is actually, the picture is very interesting. I mean, it looks like Neo4j graph or something close to it. But that's what you're saying. So the network, the intent is, as you say here, it is what and not how the network is configured. Is it?
That's correct definition of IBM system. From intent provider perspective, you tell system what is desired end state. You don't tell it, go and configure VLAN here, go and configure VRF there, right? It would really defeat the purpose.
Okay.
So, you know, in marketing terms, we say, you define the business logic, we take care of the rest.
Okay.
But the major point is not about how, it's about what you want.
So it is very interesting. So it means that from the operator perspective, not from the operator, I mean from the company perspective that is operating or who is implementing the intent-based network, and the network is more, let's say, business friendly, right? So because you're like, you speak on the customer services or the state what you would like to get from the network, not a particular configuration. The configuration of the particular network element is hidden, or let's say abstracted from the logic what should be implemented from the source perspective.
Absolutely. So decouple concerns from business logic perspective. You don't really care about low-level configuration. Your desired outcome is a working service. Is, you know, two VMs talking to each other. From low-level perspective, and this is where all the magic happening, you need to be able to understand what is the desired intent. You need to be able to decompose it into smaller tasks, right? If you say, I want two VMs to talk to each other, it might require configuration of, or it for sure requires fully working underlay. It requires configuration of some kind of overlay, because this is how we mostly do networking today. And there are many different ways. You need to configure something that will encapsulate your traffic, something like VXLAN, potentially Genève. You need to configure a control plane that could be as simple as a VPN, could be as complicated as interacting with NSXT manager or OpenStack. So there are many different pieces, and the base of IBM system, the single source of truth, needs to be able to take different pieces of information for all of the system and compose single data model that could be instantiated as network. So if you look inside, it is decomposed into configuring VLANs, configuring VPN instances. But from single source perspective, it's how you achieve your end state, which is two VM talking to each other.
Okay.
On top of that part, there's also policy part, which is very interesting. So it's not only that I need reachability, I need to build logical constructs such as VPN, right? You also need to be able to provide microsegmentation, pretty much mandatory today's networking. So ability to provide framework that interacts with single source of truth in a way that policy definitions completely decoupled from policy enforcement. Because remember, we are multi-vendor. We don't care about, we do care, but from end user perspective, end user shouldn't care whether he interacts with Juniper, Cisco, Cumulus, or anything else, right?
Yes.
So building framework that gives the ability to express your policies. And this should be completely decoupled from the way you enforce your policies. Today, you might do it on the switch, tomorrow on the host, day after tomorrow on public cloud. So it's very important to have this framework on top of your single source of truth that gives you ability to instantiate policy logic that is consumed by the single source of truth and models as part of the service.
Okay. So, and from what you explained, that's, I think the slide is perfectly decomposed into particular steps. The things you were saying, that you need to understand the business logic, then you go into the building or to designing, first of all, the service, then you're going to the building, then you're going to the deploying. Could you provide, like, for each and every step, what is in input, what is in output, you know, the kind of workflow algorithm, because that, I think that is a nutshell of IBM, if I do understand.
Oh, absolutely. So we define for full life cycle management of a network and services on top. And there are 4 phases: design, build, deploy, validate, right? Full cycle. So in design phase, we consume the intent. We are expecting end user or Sumner-bound logic to provide enough information to understand what is the intent, what is it you're trying to do. So if we take data center networking, the intent might be, I want a leaf-spine network that provides this number of ports with this degree of oversubscription. This amount of information is enough to build logical representation of the network, right? So you've just told me what you want.
Okay.
As we go towards building phase, so now we've got high-level logical network. Now I need to get more details to try to instantiate network. I need to get a interface maps. I need to know, are you going to use 25 gig ports, or you're going to split 100 gig ports into 4? Are you going to use IPv4 or IPv6 or both? Are you going to use VXLAN or something else? So there's a lot of details that need to be applied to logical abstracted design in order to be able to build a network. So in this phase, IBM system would consume metadata that makes intent actually model. So now you can model a network in a way business logic is fully understood. So next step is intent instantiation. In this step, we really instantiate what your network is going to be. So now you can tell me, my leaves are going to be Arista, my spines are going to be Cisco, and those are the model I've got. And by the way, these models have particular semantics. For example, my flooding domain could be of this size. Number of VTAPs on the switch could be this number. So all of this should be taken into consideration when modeling, because what you're modeling now is really logical network that is going to be instantiated in physical devices. So after we've matched logical footprint to physical footprint, we go into deploy phase, and where we deploy the configuration. We create configuration state in the devices. Could be done in many different ways. Some vendors give us reasonably good APIs. Some vendors support only CLI. So again, it's not a concern of consumer of IBM system. It's our concern, and it takes a lot of work to normalize all of this across all different ways to do so. I would really love to see us to provide full YANK support on every device, but it will take a number of years. We all know that, right?
Okay.
So last phase is the validation, because there are always changes. There's nothing in the network that is not changing with the time. the ability to understand the character of the change, what it means to my network, to my services, to my intent, is fundamental for full lifecycle management. So if its interface goes down, what does it mean? Should I care? So ability to correlate service characteristics to events happening in the network, which clients are affected. Is any communication affected? Is any KPIs are not met? It's fundamental for working system, because given the complexity, I don't think any human being is capable of comprehending what particular change on densely connected system would mean. So ability to create this continuous loop by gathering data from the network, and with streaming telemetry is getting better and better and closer to real time. So IBM system should be able to take this information input and understand what it means, and then either notify end user, look, there's a problem, or ideally go and remediate. So this is for changes that are not triggered. There are also changes that are triggered. Now, we add links, we add switches, we replace, we upgrade. So the intent system should also understand how to deal with planned changes. For example, I want to upgrade all my spines. How many of them can I upgrade simultaneously without affecting my services? So based on user intent, IBM system should be able to figure out you can only upgrade single spine at a time, and don't touch any other spine until I see traffic fully restored. Ability to get traffic away from the system that's going to upgrade must be there. It's not necessarily visible. It's done implicitly, but you need to be able to say, I'm going to upgrade the switch, right? This is your intent.
Yes.
The rest of the logic is really within the system. Let's change routing policies. Let's shut down something. Let's do things that will divert traffic away from the node that's going to be upgraded, restarted, change it in a way it doesn't affect my services. Okay. So what you see is really a full loop of life cycle. And at any point, if you design something new on your network, you will go through exactly the same cycle. You will provide your intent, you will model it, you will attach physical resources to logical resources, you'll instantiate your network, and you'll go into validation.
I think validation part is very important, because the example that you provide, I'm just thinking about it. So it means that so the system should be able to understand. So based on the load, I don't know, interface utilization 50% or 70%, it should be able to calculate and say, okay, based on this traffic profile, you're able to touch only one switch in order not to impact the customer service. So you need to do it like one by one, or the same probably with leaves, like if you have redundant connectivity or not, if you are able to update the switch now, or it will impact the service of the customer. Is this correct?
Yeah, and this is very basic logic, right? You could go into more interesting use cases, for example, when overlay is provided by someone like VMware.
Okay.
So if you see that utilization on links, and in this case, it's not single link. So you need to understand average utilization over your ECMP fan out, right? So you need to be able to say, show me average utilization over all my leaf to spine links over the last 20 minutes. And by the way, this is another property of an IBM system that should be there, because single interface load means nothing. You might just be unlucky by hashing elephant flow to a particular link, right? So you need to take your network as a whole, tag particular points that are of interest, for example, leaf to spine links, and tell system, I want to know particular property of particular set of my objects over a particular number of time, right? So going back, if you see it goes over 50%, for example, you would communicate back to such an overlay or cloud management system, start vMotion, migrate your workload somewhere else, instantiate your Kubernetes pod somewhere else. So when you make this interaction working, now it becomes really interesting, much more complex, because someone still has to do single source of truth to understand. But I think this is where we are going long term. We need to make sure that networking ecosystem is capable to talk to each other, using common APIs, and 1 + 1 is more than 2 in this case.
Okay, I see. Well, that's really interesting, and that is a problem that we was discussing. I think we already probably covered this, but this is exactly the point that we was touching. So something that is planned, that is obviously should be fair, easily to understand how to tackle with, and something that is not planned. I mean, like you have link outage or whatever else. Yes.
Even for planned changes, I mean, how many of us have been 2 o'clock in the morning in the data center replacing stuff, and then you see stuff is just not working, and it's 3 o'clock and 4 o'clock, and you start thinking. Right?
Yes. Yeah. I could fully understand, and it's probably with
ability to roll back, ability to kind of say it's 4 o'clock, I cut down, I completely roll back all the changes I was planning to do. It's very important from operational perspective, right? So ability to understand impact of doing or not doing particular things on your network is, again, fundamental to an IBM system, because you know what it should be, you know what it is. So we know the intended state. Thanks to analytics, we know the operational state. So we can derive from combining this to what the impact is going to be due to the delta between operational and intended states, if this makes sense.
So it means that kind of simulation, I mean, analysis, simulation, whatever we call it, of your plan changed, and it is a must-have part for any IBM system in order to be able to analyze how your change will impact the network, correct?
I would say it's more an application of IBM system, and I wouldn't call it must-have. So
right.
Before, if you look at traffic engineering days,
yes,
you would have a system such as Keridon, for example, that would give you the ability to say what happens to my links if I shut down one link, if I reroute, if I do something with it, right? So IBM system as such, it doesn't require you to do if-else analysis because it understands your intent. It wouldn't allow you to do something that makes your intent not operating, right? So you don't do it by yourself. System does it on your behalf. So for example, if you need more than 50% capacity and you've got 2 switches that provides this 50% of capacity, you can only shut down one of them at any given time. So system will take care telling you, look, you cannot go and shut down second switch because due to physical limitations, you won't be able to achieve the amount of bandwidth you needed to.
But it is even better because it's, as you're saying, it does not prevent you to harm your own network that you might do unintendedly or without wanting, but if it is protected, that is even better.
So I don't think there's any operator that would go and, say, I'm not touching CLI, we are done. And from IBM systems perspective, this is the end goal. You shouldn't be touching CLI. It should really be some sort of last research for debugging, not for configuration, God forbid, for changes. And as we said before, the configuration is rendering of your intent. If you go and configure something by hand, your intent is still old, but your configuration is different. And it's pretty much impossible to infer what you really meant. Imagine you configure static route on a system. There could be millions of reasons to do so. But from IBM system perspective, you've just broke the most important part. Your operational state is not in sync with your intent, and system doesn't know why.
What? Okay, that I understand. It's a very interesting point. But as we were talking just a couple of minutes ago, so how often we need to wake up in the morning and go troubleshooting stuff? How would then this troubleshooting, let's say, exceptions would be handled by intent-based system? Because it's something that you need to do manually, right? Because you're like intentionally broken.
So going very, very back to automation, a lot of troubleshooting could be automated, right? We've established about 30 years of practices, how things are troubleshoot, what lead to what. And if you understand your network, if it's properly modeled, it becomes reasonably easy. Let's take a few examples. Underlay, I've got 4x2K network. So 8 nodes in total. From underlay perspective, what should I see? I should see 7 remote loopbacks, 1 local. I should see BGP sessions or whatever protocol you're using to exchange reachability up. I should see write next hops on all my routes. So we know what we should see. If you're capable of modeling what should be seen and then compare it to what you retrieve from the network, you've already achieved 70% of the troubleshooting. You know exactly what's not working. So if you see missing next hop and BGP session is up, you would move to next object in your tree to look. If you see the BGP session is down, you might do some automatic investigation why it's down. You might look into what notification were received. There's a lot of stuff we know how to do. It just, before we had to do them automatically, not per node basis. Now you interact with network of the distributed system. Okay. And going into more complicated parts such as EVPN. EVPN is very complicated set of protocols, right? And set of states. So, but they're very basic things. You need to see IMET routes for every system that participates. You need to see number of things that are mandatory for working EVPN system. So if you could say, those are nodes that participate in EVPN, and those are objects that should be there. Now you can go retrieve all the state from the system, compare your intent of what should be there versus what's there. If they match, your system is working. You could use more advanced tooling that's becoming available right now, such as in-band telemetry. Different vendors call it differently. It's in-band telemetry for Barefoot. It's IFA for Broadcom. It's just in time for Mellanox. But the idea is the same. As you traverse a switch, you add some metadata, and now you can provide proof of transit. You could figure out what was going on the switch when you were traversing. So a lot of data. So the more data we get, the more comprehensive system becomes in terms of visibility into the network and troubleshooting. And not only post-factum when problem actually becomes a problem, but just before it could happen. So if you see number of errors, if you see stuff that's unhealthy and happening, you could go and remediate before problem actually happens.
Okay, so what I can take out from this point that it's actually the more telemetry, or yes, in-band telemetry or traditional streaming telemetry we more collect, the more sophisticated logic we can build in terms of what to analyze, what things to correlate, correct?
Not 100%.
Okay.
So it's very important to know what telemetry is meaningful. So if you look at most systems today, they'll tell you the more data you give me, the better I am, right? So you create data lakes with terabytes of data you never look at.
Sure.
So it's fundamental to 80% of your telemetry to be meaningful. And if you cannot understand what it means to you within a segment or two, it's pretty much meaningless. So there's some data that is needed to do planning, to do trending analysis, but this is independent. However, you obviously need to get some basic data that is mandatory for visibility to a system. However, it's pretty much 5–10% of the data you need. All the in-depth data is only needed when something is wrong, because otherwise it's good. You do nothing, right, when it's good. You don't fix what's not broken. So ability to request in real time all this additional data, drill down into particular problem as you go through decision tree is fundamental to scale, because you're going to see larger and larger networks. There's more and more demand for more workloads. They become more distributed. So complexity is growing no matter what. And ability to say, I need to see this additional piece if this piece is not right, is fundamental for a system to be able to scale.
Okay, so now it is getting more clear. So basically we need telemetry or any additional data only if something's going wrong to identify what is actually going wrong, because we don't need, as you say, all the data by default, correct?
Absolutely, and it's fine tuning to figure out what you need by default versus what you ask for afterwards. And we are constantly working as a company trying to find out right balance. So we don't want you to store terabytes of data just for sake of storing it. It's expensive and it serves no purpose. So from my perspective, if you cannot do it in memory within a second and you don't do any trending or window or timing analysis on it, you just throw away the data. Or you just stream it to someone else to store it. It's not part of IBM system to become a data storage lake and trying to look into terabytes of data over 3 years trying to analyze it. It should be somewhere else.
Okay, thank you. Because I think it is really important because, you know, I also doing some tests, some let's say exercise in terms of collect data, and even if I'm trying to use a standard telemetry data using streaming telemetry, the amount of so counters or anything that I'm able to extract from the streaming telemetry data models, it's really huge. And if I need to do it each and every 10 seconds, how it is supposed to work, streaming telemetry, that's a madness. I mean, even in one day from one device, I'm really connecting a couple of megabits of information. And if you multiply by the network size, it's unreal to save everything.
Absolutely, and it's becoming more and more, right? We are finally getting hardware telemetry.
Yes.
So GNMI, which is probably a topic for another discussion, has become finally de facto standard in networking. And we could subscribe to any event of the system, and it's really great stuff, but the amount of data we are getting is really significant. So it's not a new problem, right? Big data has been around for quite some time, and most companies just ended up having this huge lake doing absolutely nothing. So the intent of, no pun intended, intent of intent-based networking is to make sure that you are only getting data that is absolutely mandatory for you to assess your operational state. The rest of the data should be able, we should be able to request it on demand as needed based on the state. Another interesting point, the way IBM models its networking state decouples how you ask for data, because today your network is, again, 2 by 4, right? So you've got 8 devices in total.
Yes.
If you add 4 devices more and you tag them as leaves, you don't need to change any props. You just added 8 more links of type leaf to spine. So when you ask, show me all links of this type, you're just showing more links without changing any props, right?
Yes.
It's just an object in the graph with particular relationship that is a link between leaf and spine. So you decouple size of your network, complexity of your network from how you probe it in logic.
Okay. Yeah, I think it is really a great approach in terms of taking only what is necessary, when it is necessary, and why it is necessary, not just collect everything that we do here. I think our time is slowly going down. Frankly speaking, thanks for this discussion, because I myself, though I have heard about the intent-based network earlier, learned a lot of interesting concepts today that would help me to understand much better what is happening on in the network. Just one question more. I really was thinking, because, you know, the topic of intent-based network is not necessarily related to the data center. Probably data center is easier because you could have, I don't know, easily switch the device or update. But what do I think? Does this concept of intent-based networking applicable to service provider network, to enterprises, or pure data center stuff?
I think it's a very good question. So if you look at modern data center, it's a highly regular topology. In most cases, it's a variant of leaf-spine network, 3-stage, 5-stage, 7, could be 9 if you're very large, right? But it's easily modelable. So in order to be able to reason about why your network the way it is, you need to have proper representation of your networking graph that is understood by the system. So data center are the, if not the easiest part, it's the, I would say, right point to start, because there are many devices. They're densely connected. It's very complicated to troubleshoot. So if you're talking about Apstra from startup perspective, it was the right space because this is where the most complex things are happening. If you go to service provider networks, in most cases, they're designed by the people and in a way people imagined, right? So you get another person, you see design changing. After 5 years, you have no idea why your network looks the way it should. So from service definition perspective, and as you know, in ATF, we did L3SM model for service model for L3 VPNs. You worked on it. Great work, by the way. You could pretty much build a service, but it's completely decoupled from the rest of the network, right? So there are points of service delivery, and you model how service should look between them. But all the service, all the underlay traffic engineering, all the stuff that below it is not really connected. So going to one of my most favorite topics, young data models, it's very difficult to, if not impossible, to build a full slice of services from optical up to service layer, right? So we've been trying for many, many years. This is how we started ODL, optical part, in Ericsson in all days.
Okay.
But the correlation between different layers, trying to model your intent, is still to be done outside of data center. I think it's an extremely complicated topic. There are people doing it successfully at particular layer. So there are a number of companies that are doing really good work on optical layer. There are a number of companies that do it well on the layer 3, so Cisco, Juniper, Nokia, right? But building it all together, it's yet to be done. So I think data center is a very pragmatical first step for IBM to start with.
Yeah, I fully agree with it, because I was thinking there are all the design that are the service provider, though actually I think there are, with the dates, it's going a lot of commonalities between their building kind of fabric topology in the access network or core network, and having the fabrics in the data center. Yeah, it's going common, but still, probably it's still a way to go for in that direction.
And I think another point is that every service provider network is snowflake in its nature. And it's not always because different people had different views. It's often bound to your optical topology, right? The way your fibers laid out. I mean, if you have no fiber in the ground, it doesn't really matter what you design on top, right? In data center, the connectivity is extremely regular. Everyone is connected to everyone. It's densely connected graph. So we know exactly who should be connected to whom. And again, we could do validation through LLDP, some other means, but it's much easier and well understood connectivity patterns compared to service provider network where it's multi-layer, and again, it's snowflakey.
Okay. Thank you very much for your time, Jeff. Today it was very great discussion. Very appreciated. And probably we will discuss some other hot topics that Jeff is working in the IETF groups. So stay connected. Thanks a lot for your time.
Thank you for having me over. It's been my pleasure, and I'm looking forward to talking again.
Thank you.
Cheers.